Welcome to the presentation of Theories of Evolution. Today, we'll cover key theories and contributors to our understanding of how species change over time, including Charles Darwin, Jean-Baptiste Lamarck, and Hugo de Vries. Darwin's famous work on the origin of species describes the tree of life, where all species share a common ancestor and evolve through a process of branching, resulting in biodiversity. Jean-Baptiste Lamarck, a French naturalist, proposed that organisms can pass on traits acquired during their lifetime to adapt to the new environment to their offspring. He called this the theory of inheritance of acquired characteristics. Lamarck suggested that environmental changes cause organisms to develop new traits. For example, giraffes stretch their neck to reach high branches, and this trait is passed down to the next generation.
Charles Darwin revolutionized evolutionary biology with his theory of natural selection. He observed that traits that increase survival are more likely to be passed on, leading to the evolution of species. Natural selection requires heritable variation in a population. If a trait helps an organism survive, that organism will reproduce to more, passing to the advantageous trait on to its offspring. Darwin's famous work on the origin of species describes the tree of life, where all species share a common ancestor and evolve through a process of branching, resulting in biodiversity.
Hugo de Vries introduced the mutation theory, proposing that evolution is driven by sudden inheritable mutations rather than continuous variation. Mutations provide the raw material for natural selection. De Vries' research on evening primroses showed that new species can arise through mutations, with new traits appearing in a population unexpectedly and becoming permanent through inheritance. The modern synthesis, also known as Neo-Darwinism, combines Darwin's natural selection with Mendelian genetics, explaining evolution as changes in allele frequencies within populations. Gregor Mendel's work on pea plants showed that traits are inherited through discrete units called genes. These genes, now understood as alleles, provide the variations necessary for evolution through natural selection. In population genetics, evolution is defined as changes in genetic composition of a population over time. Factors like mutation, genetic drift, migration, and natural selection drive these changes. Natural selection is a key factor in evolution, favoring organisms with traits that increase their fitness in a particular environment, allowing them to survive and reproduce more effectively.
George Gaylor Simpson, a paleontologist, showed that fossil evidence supports evolution through natural selection. His work helped bridge the gap between genetics and paleontology. Simpson argued that evolution follows a branching, irregular path. Species don't evolve in a straight line. Instead, they diverge into multiple directions, with some branches leading to extinction.
Darwin's idea of survival of the fittest means that organisms best suited to their environment survive and reproduce. However, this doesn't mean the biggest or strongest, but the best adapted. Lamarckism has been largely discredited, but it laid important groundwork for future evolutionary theories. His idea that organisms adapt to their environment, though oversimplified, sparked further research.
Today, we understand evolution as a complex process involving genetic mutations, environmental pressures, and natural selections. These factors shape the diversity of life on Earth.
In conclusion, evolutionary theory has evolved itself from Lamarck's early ideas through Darwin's groundbreaking works to the modern synthesis, integrating genetics with natural selection.
Thank you for your attention. Evolution remains a central theory in biology, explaining the diversity of life and how species adapt and change over time.